Hey everybody, hope you are doing well. We are going to start into our naming polynomials and introducing them and what is a polynomial and all of the verbiage behind it. So we'll start getting into it so you can write your own definition in the end. So the vocabulary word is a polynomial. And that's what we want to talk about. So a polynomial is a few different things. First of all, it's made up of constants, so numbers, variables, so letters, and exponents. I can zoom in a little bit more because I'm writing a little big. Exponents must be positive whole numbers. So therefore, no fractions or decimals, and no division by a variable. No division by a variable. So in other words, it's made up of constants, variables, and exponents, so numbers, letters, and exponents. The exponents have to be positive whole numbers, so they have to be no fractions, no decimals, and they have to be positive. And there cannot be a variable in the denominator. So some examples here. 5x cubed plus 14x squared minus 8, that's a polynomial. 3/4 x to the 5th minus 16x to the 84th, that's a polynomial. 3/4x, that is not because there's an x in the bottom, but you could have 4/3 x or something like that, or 6x squared y squared equals, minus y. All of those are examples of polynomials. Not examples, square root of x is not a good example. 8x to the 1/4 minus 5, 3/x squared, all of those are not examples. All right, so let's look at this. Let's circle each example of a polynomial and place an x over each example that is not. Let's just cross them out. So this one's good. I'll just go across. 0.75 is an example. That is no bueno, no good. If I go down here, this one's good because it's just a number in the bottom. X is an exponent. That's not good because it's not a positive whole number. This one's got the absolute value, so no good. This one's good. It's just a number times, that's good. This one has the square root of x. Square root of x, that's x to the 1/2 power, so that's no good. This one's good. This one's good. Here the y is in the bottom, so that's no good. So it's just looking at different examples, making sure you know what's going on. You can spot one. All right, important vocab. So first of all, we're going to talk about the degree. So the degree of a monomial, or just a single term, is the sum of the exponents of the variables. The degree of a polynomial is the highest exponent or sum of the exponents of a single term. Important, single term, not all of them. Standard form of a polynomial is the polynomial's terms are written in decreasing order by the value of its degree. So if we're looking at different things here, kind of so you can see it, went ahead and color coordinate it so I can talk through it. So the degree of a single term is just the sum of the exponents. So 6x to the 8th. 8 is the only exponent, so 8 is my degree. The second one, I got x to the 6th, y to the 3rd, z to the 1st. If it's not written, there's an automatic 1. 6 plus 3 plus 1 is 10, so that's a degree 10. 8 doesn't have a variable. There is no variable, so it is just a degree 0. It's just a constant. The degree of a polynomial, we look at each section. So the first part, 2x to the 5th, has a degree of 5. The second part has a degree of 10 because 6 plus 3 plus 1 is 10. 5 plus 2 plus 4 is 11 for the third part. 11 is my highest, so 11 is my degree. We are not adding them together. It is just the largest piece. So we're finding the degree of each monomial here. Z to the 6th, that just has a degree of 6. 4a squared b to the first, 2 plus 1 is 3. 7 does not have a variable, so that is a degree 0. It is a constant. And then 5x to the third, y to the second, 3 plus 2 is 5. So we're adding the variables or the exponents of just the variables here. All right, so let's start classifying these. So every polynomial is named according to their degree and their number of terms. So if we look at the first part, it's just the degree name. So every polynomial will get a name based off of its degree. So if it's a degree 0, it's a constant. So 7's an example, negative 13, just a number. Degree 1 is called linear. It's a line, so like 7x plus 3. Degree 2 is a quadratic. So 3x squared minus 4x plus 2. Degree 3 is a cubic. So 4x cubed plus 3x squared minus 1. Doesn't have to have everything, it's just the largest one. 4 is a quartic. So 2x to the fourth minus 3x. 5 is quintic. So negative 3x to the fifth. I don't want to write a whole bunch, minus 1. And then if it's 6 or more, we're just going to call it like 6th degree or 7th degree. I started writing it. So 6th degree, 7th degree, so on and so forth. All right. So everything's going to get a name based off of its degree, depending on what degree it is. It's also going to get a name by its terms. So how many different spaces it has. So the term name, if it's only got one term, it's called a monomial. So 3x to the fourth or 7 or something. 2 is a binomial. So 2x cubed minus 3. 3 is a trinomial. So x to the fourth minus 3x squared plus 2x minus 1. That's a polynomial. I got ahead of myself, so let's just erase that. And then 4 or more. 4, so polynomial, poly meaning many. So 4 terms, give or take. That's an example. All right. So here, let's look at it. The last thing that is important is the leading coefficient. So the leading coefficient is the number that's in front of the highest degree term. So if you look in that blue box right here, I have a degree 2 because that's my largest exponent. The middle one's a degree 1. The last one's a degree 0, so 2 is the largest. My leading coefficient is the 3 that's in front of it. If I named it by number of terms, I have 3 terms, so that would be a trinomial. So let's look at 2 of these before I turn you loose for today. So we're going to rewrite it in standard form and name everything. So standard form. My largest exponent is 4, so 8x to the fourth, then 3x squared minus 4. All right, my leading coefficient is the number in front, so an 8. My degree is the largest exponent, so 4, 2, 0, so 4 is my degree.